Okay, here we're going to discuss how we can analyze the speed of an object that is moving in a straight line using its velocity and acceleration. So this concept applies to any object that is moving in a straight line, and for the purposes of this particular video, we are going to reference a particle that is moving horizontally. So a positive velocity will reference moving to the right, and a negative velocity moving to the left. Now, it is common that we are either given the velocity function, given a graph of the velocity, or that we are able to get the velocity easily either by taking the derivative of a position function or taking the antiderivative of acceleration. And while we're given the velocity, it's easy to get the velocity, we're often asked or want to know something about the speed of a particle. And remember, of course, the relationship between velocity and speed. They are similar but different. A velocity has a directional component, the sign matters, whereas speed is simply an absolute value, right? It just tells you the absolute value of velocity. How fast are you moving? And doesn't care about direction. A great example of this is if you're in your car and you put the car in reverse and you press on the gas, you look at the speedometer and it doesn't go negative. It's a speedometer. It measures your speed. It is not giving you a directional component. Now, we're going to start off by looking at how we can use the graphical representation to make sense of this situation, which I think is the easiest, most straightforward method. So if we have a graph of velocity, or perhaps you're able to sketch a graph of the velocity curve either by hand or with your calculator, you want to take advantage of the fact that speed is simply the absolute value of velocity. Using this, we can then sketch a graph of the speed of the object or particle very easily, simply taking the absolute value of all the velocities, which takes all of the negative velocity values and reflects them over the x-axis. Doing so makes it really easy to answer the questions, where is the speed increasing and where is it decreasing? You can see very clearly that it's going to be increasing on the interval from 0 to a. It's decreasing from a to b. It's increasing from b to c. It's decreasing from c to d. It's increasing from d to e. And it's decreasing from e to wherever this final point is. So graphically, quite easy. If you are using a graphing calculator to find these points, what you're looking for to determine these particular points is a relative max or min in that region. So when you go to find a maximum on your calculator, you can set a left bound and a right bound, and that way it'll look for the maximum only in that area. So you can find where those points are on your calculator. All right, now let's go ahead and answer the same questions about speed at a given point using the values of velocity and acceleration. So if we're at any time t, the velocity has three possibilities. We can either have a velocity that's positive, a velocity that's negative, or a velocity that is zero. So let's consider each of those situations and think about what would cause the speed to be increasing or decreasing. So we'll start with the velocity being greater than zero, which means you're traveling to the right. What type of an acceleration would cause your speed to be increasing? Well, if you're traveling to the right and you want to be traveling to the right faster, then the acceleration needs to make your velocity even more positive. In other words, you need a positive acceleration. So if velocity is positive and the acceleration is positive, then speed is increasing. Now, similarly, if we're traveling to the right, if the velocity is greater than zero, and the acceleration is negative, that would mean that the acceleration is causing the velocity to decrease, which would mean that our speed is also decreasing because while we might still be moving to the right, we're moving to the right at a lower velocity. So if the acceleration is less than zero, we can say the speed is decreasing. One quick note, what I'm using these plus signs for is just to simulate an and. So if velocity is greater than zero and acceleration greater than zero, speed is increasing. If velocity is greater than zero and acceleration is less than zero, then speed is decreasing. All right, let's consider the case where the velocity is negative, and that of course means that our particle or your object is traveling to the left. Now, if you're traveling to the left, what would make your particle travel to the left faster? Well, your velocity is already negative, so if the acceleration is negative, that would mean that your velocity is getting more negative, which means you'd be traveling to the left faster. So in this case, if acceleration is less than 0, the speed is increasing. And not surprisingly, if your acceleration is positive, that means your velocity, which is negative, would be getting a little bit less negative because the acceleration would be pushing it sort of in the other direction, which means you'd be traveling slower to the left. And therefore, if acceleration is greater than 0, you're going to have a speed that is decreasing. So last, we have the case where your velocity is 0, and if your object is currently standing still, then no matter where it moves, either to the left or to the right, your speed is going to be increasing. So as long as your acceleration is not 0, then your particle will be in the midst of speeding up. All right, so now you see how you can justify that the speed is increasing or decreasing, and that's just as important as being able to tell whether it's increasing or decreasing. If you can say the velocity is greater than 0 and the acceleration is greater than 0, then speed is increasing. If you can say the velocity is less than 0 and your acceleration is less than 0, then your speed is also increasing. All right, notice that in both cases, the velocity and the acceleration had to have the same sign. Either both were positive or both were negative. Similarly, if your velocity is greater than 0 and your acceleration is less than 0, then your speed is decreasing. And if your velocity was less than 0, but your acceleration was greater than 0, then your speed is also decreasing. In other words, if your velocity and your acceleration have different signs, then the speed has to be decreasing. So that's sort of the quick and easy way to remember, right? If the velocity and acceleration agree in their sign, then your speed is increasing. And if velocity and acceleration have different signs, then the speed is decreasing. However, when you're justifying this on a free response question, the way that you justify it is just as we've written here. So I might say speed is increasing at t equal 3, for example, because the velocity at 3 is greater than 0 and acceleration at 3 is greater than 0. And I would obviously show my work finding the acceleration and the velocity at those points. So make sure that you understand how you can justify and how you can decide whether the speed is increasing or decreasing at a particular point.